are usually not a number that I like to skip count by. Some of you could, but I think for most kiddos, skip counting by 9s is not really a good time, which is totally fine. It doesn't have to be. It's not a good time for me. My brain does not skip count by 9s. However, I know that my 9s and my 10s are really close together, so I'm wondering how might my 9s and 10s be related? Once you get to your next blank page, put the title multiplying by 9s, and then I want you to write a sentence or two explaining how might your 9s and 10s be related. How could they be related? I heard you guys talking to your neighbors. Aiden, what you think?
I thought they were related because they were, it was one less.
What is one less?
9 is one more than 9 is one more than 10, and 10 is one less than 9.
What?
9 plus 1 equals 10.
Okay, so 9 is 1 less
Than 10, and 10 is 1 more than 9.
Good. So we have 9 is 1 less than 10, with 10 being 1 more than 9. That's definitely how they could be related. I know my 10. That's easy peasy. Kaiser, what did you guys talk about?
I think 9s and 10s are related because they're both counted as preteens. For example, 9, 10, 11, and 12.
Okay, is that going to help me with any kind of math? Not really. Lucy?
You say the same time because if you have 9 times 10 times 9, you can make up the 10 to the 3.5.
Okay, so both 9s and 10s can be broken up. Using that break apart strategy that we use for mental math a whole lot. Mason?
If you count by 9 and 10, you count by 1, and get stuck on the order, you can just count 2 times.
Okay, so we can use what we know about our 10s to help us figure out our 9s because they're so close together. What you got, Cheyenne? Good. Good. You should have something written in your notebook. Something. Alright, we are going to look at an array. So go ahead and get out your counters. Move your notebook just to the side. We're going to need it. And I want you using yellow, yes, to create a 10 by 3 array. And I want an array, not a fast array for this one. A whole array. 10 by 3, please. Alright, so I've got a 10 by 3 array, or 10 groups of 3. Even if you're not done building, do you understand that that's a 10 by 3 array? Yes. Awesome. If you're not done, still just use my array for right now. If you're not done, just use my array. It's okay.
I don't have enough.
Problem solved. How can I turn my 10 groups of 3 into a 9 by 3 array? What do I need to do? I want to take my 10 by 3 array, and instead of being a 10 by 3, I want it to be a 9 by 3. What am I going to do? Courtney, what am I going to do? One group of...
So, for the 10, we can take one of that away.
One of what? One group of what? Nope. Quit messing with your counters. Hey, dear, that includes you. I'm at 10 by 3. How am I going to turn that into a 9 by 3? What do I need to change? Parker? Take away one what? One group of 3. Remember, guys, look up here and leave your counters alone. If I have to say that again, your counters will be mine. This is said 10 groups of 3. To make that equation a 9 by 3, I need 9 groups of 3. I'm taking away one group of 3. Take away one group of 3 if you've made your array. Georgiana?
That's
What is 10 times 3? 10 times 3. What's the product of 10 times 3, Dylan? 30. If I was at 30 and I took away one group of 3, what's going to be my new product for 9 times 3? I'm at 30, 29,
28, 27.
Here's my group of 3. So what is 9 times 3? Oh, Gabriella?
9 times 3
No, we just did it together. Sam? Is 27. Put your counters up because too many of you are playing with them instead of being up here with me. So put your counters up. So again, we're going to be drawing this time a 10 by 6. And we're going to use 10 by 6 to help us figure out 9 times 6. What you're looking at. And then I want you to write out what 10 by 6 means. We know that means 10 groups of 6. What is 10 groups of 6? Eva? 60. What if I wanted to use that easy peasy problem to solve 9 times 6? Now I want to solve 9 times 6. How do I read 9 times 6 though? What does that actually mean, Kaiser?
9 groups of 6.
9 groups of 6. So what am I going to do to get from 10 groups of 6 down to 9 groups of 6? What do I need to do? I had 10 groups of 6, and now I want to get to 9 groups of 6. How would I do that? Lucy, how would I do that?
I'm going to take down one line of groups of 6.
I'm going to take away one group of 6. Now I have a 9 by 6 array. I could count all those pieces, but I'm going to use what Lucy just said to figure out what is 9 times 6. I started with 60. I'm taking away one group of 6. So I'm going to just count backwards, so that's not a big subtraction. Start at 60, 59, 58,
54.
54. So what does 9 times 6 equal?
54.
Did you have to skip count by 9s to figure that out?
No.
Did you have to do a whole lot of counting to figure that out?
No.
Did you have to figure out how to skip count by 6s?
No.
No. You're able to use what you know about your 10s, figure out your 9s. Think back to what Aiden told us right at the beginning. He said, hey, our 9 is 1 less than 10. When we're doing multiplication, our 9s are 1 group less than the 10s. Right? Sure? 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 Cord?
When I like to count them by tens and then go back through them and then subtract those.
That's exactly what we just did. Perfect. Cord said, what I like to do when doing my 9s is I do it by 10s first, and then I just subtract the group. So if I was doing 10 times 3, 10 times 3 is 30. We're doing 3, so I'm going to subtract 3. 30 minus 3 is 27, so 9 times 3 is 27. In our case here, we did 6s. 10 times 6 is 60. Just subtract what you're multiplying by. Okay, I'm multiplying by 6. 9 times 6 is 54. Faisir?
I see a pattern
Go for it.
in the 9s.
Go.
It should be down here.
We're going to find our mini multiplication chart. There's quite a bit already filled in. And even though Susie just taught us a really cool trick and we know how it works, we're going to practice using our 10s to get our 9s. Okay? Let me go find mine. Alright, so I have 9 times 0 is what? 0. 9 times 1. Okay, well I know not 10 times 1 is 10, and I'm multiplying by 1. 10 take away 1 is 9. 9 times 2,
18.
10 times 2 is 20, and since I'm multiplying by 2, not 20 minus 2 is 18. 3, 9 times 3, 3 times 10 is 30, minus 3 is going to give you what?
27.
27. 9 times 4, 10 times 4 is 40. Subtract 4,
36.
36. 9 times 5, 45. Most of you choose to skip count by 5s for those. Alright, 9 times 6. Well, 10 times 6 is 60, minus one group of 6,
54.
54. 9 times 7, well, 10 times 7 is 70, minus one group of 7,
63.
63. 9 times 8, well, 10 times 8 is 80, subtract
72.
a group of 8 is going to leave me with 72. 9 times 9,
81.
81. Am I done?
No.
McKenna, am I done?
No.
No. Why am I not done?
Because you have to do it on the rows.
Okay. Why can't I do it on the rows?
Because it's the property which says that you can do it
Table 3.
side to side or up and down as long. And the product is going to stay the same.
Yes, I can go across as well and change the order of my factors, and it's not going to mess up my products at all. So 9 times 3 is 27. 9 times 4, table 3, stop making noises. is what, 36, 54, 53, 72. McKenna, what's up?
I realized that when in the tens place, you're going 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yep.
And in the ones place, you're going the opposite way.
Alright, so just to show you what McKenna is talking about, she said, hey, when I'm looking at my products, let's just say I'm going down, it's going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in my ones column, it's going the other way. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
It's counting down.
Why is it doing that? Because it's really close to 10. It's only one less than 10. So my ones columns are getting smaller and smaller by 1 every time. Pretty cool. Yes, ma'am, Natalie.
I have a question.
Go for it.
If we're doing 1 minus 10 when we do it,
Uh-huh.
could we do 2 minus 10 when we do
Kinda.
9 minus 10?
Kinda. It gets a little hairy when you do it that way, but kinda. Kaylin?
Also, if you're very close, when it's going 18 to 6,
Uh-huh.
when you keep on going, the numbers are going up. So, like, there's 36 and 63.
Oh, that's a good point. So 54, and then if I were to switch my tens and my ones, is 45. And if I have 36, and then switch my tens and my ones, it's 63. 27, if I were to switch my tens and my ones, is 72.
I know it's that.
18, if I switch my tens and my ones, is 81. Nines are full of patterns. Full of tricks and patterns along the way. Grace? Gabriella, put your water bottle on my desk since you're choosing to not drink out of it correctly. Yep. Yeah, we need to read it. Mason, can you read this problem for us nice and loud? Alright. We got Eric. Mowing lawns, making money. We want to know what? What are we trying to figure out, Cheyenne? How much money did he make last month? So we've read it, we get it, we got it. What's my second step? Tajir, get it going so we can move on. Lucy, what's my second step? What am I trying to count in this problem? What? Money. Dollars. I'm counting money. What's going to be my answer sentence then for this problem? If you already have an answer sentence, go ahead and start writing it down. Georgiana, what you thinking for an answer sentence?
Money on the lawn team.
He made blank. Now we normally don't say money. We normally say
Cash.
you could say blank cash. Usually, what do we call money though?
Dollars.
Dollars. So you could say money, but usually we call money dollars. This is your answer sentence. You can have some variation. It doesn't have to be exactly what I wrote, but it does need to make sense. It needs to be blank dollars, blank money. Trying to figure out how much money he made. Parker, stop doing that. All your pages are coming out. Alright, next, we need to make a plan. That means we have to figure out what math am I going to use. Add, subtract, multiply, divide, make it up, I don't know. This is where we need to draw our skinny bar model. We know, what does the bar equal? What does the bar equal? Equals the same thing every single time. McKenna, what does the bar equal?
It equals the whole.
The whole. The whole. What are we counting? We're counting dollars. So this is the total dollars. The whole amount of money. W for whole. Do I know the total amount of dollars?
No.
No, that would be really convenient if I did. Nowhere in that problem does it say he made blank money last month. Does it say that? Does it say that, Lucy? Does it say that, Ella Harris? It's a bummer. No. So do we know the whole?
No.
No. Sad face. I don't know the whole. What do I know? What do I know? All you gotta do is look back at the problem. It told you some stuff. What do... No, sit down. Bummer. Sit down. Ella Harris, what do you know? Every time he mows a lawn, he makes $9. That sounds like a group to me. How many groups, or in this case, lawns, did he mow? Caleb? 4. I'm going to break up my bar into 4 boxes. And those 4 boxes represent lawn 1, lawn 2, lawn 3, and lawn 4. I know he mowed 4 lawns. It told me that in the problem. So here are my 4 lawns. Ella Harris, you already told us, but how much money does he make mowing 1 lawn? $9. So here's yard 1, $9 for you. All right, what about yard 2? $9. What about yard 3? What about yard 4? There's 2 different equations you could make. You could use what we did with part whole and use what operation? When we do part whole, what math skill am I using? Right here? Addition. Can you make an addition equation with that, right here? Go for it.
9 plus 9 plus 9 plus 9.
Equations have equal signs.
Equals
I could make an addition problem. This is just like when we did part whole. Part plus part plus part plus part equals our whole. What other equation could I make though? Because that looks a lot like repeated addition to me. It's a lot like repeated addition. What do you think, Cheyenne?
4 times 9.
I have 4 groups of 9, so I could say 4 times 9 equations have equal signs. Box, square, T, I don't care. T. Could be a letter. Snowman, like we're doing in our Christmas math. Alright, what am I going to do now to solve that problem? 4 times 9. Could you skip count?
Yes.
Could you do the trick that Ford and I talked about, where you do 10 and then subtract 1 group?
Yes.
Could you do your doubles, because it's 4s? Pick a strategy and work it out in your notebook. I don't care what strategy you choose, but choose one and go to town. just looking at our repeated addition equation, could you do double and double?
Yes.
Yes. What is 9 plus 9?
18.
18 plus 18. Dylan? 36. Is this the way you did it? Yeah. Could you do, let's say I have 4 times 9. Could I break up my 9 into easier math factors?
Yes.
Yes, this is like Georgiana's favorite way. Georgiana, did you break up a 9? How did I know that was going to happen? What did you break it into, Georgiana? A 4 and a 5. So now we have 4 times part of our 9, which is 4. Do you know what 4 times 4 is, Georgiana? 16. Plus 4 times the other part of our 9, which is 5. Georgiana, what's 4 times 5? 20. 16 plus 20. 36. That works. Could you use your 10? Yes. We're doing one less group because we have our 9s. So 4 times 10 is 40. And I'm going to take away one group of 4.
40 minus 4 minus 4
40, 39, 38,
37, 36.
I don't care which strategy you like, but find one that makes your brain happy and go with it. If you are a skip counter and that's your jam, go to town. If you are like Georgiana and I and you like to break up a number into easier factors, go for it. If you have other tricks that your brain likes, go for it. How much money did Derek make last month? Courtney? 36 what? That's a naked number.
36.
36 doll hairs.
What?